The next speaker is, I'm really looking forward to it because sometimes things you don't think about are the most important. And Klaas Moser from the company Lankwitzer will now tell us why insulations in batteries are important and why they need to be durable as well. Mr. Moser, the stage is yours.
I'm ready. I'm sharing. Let me see. Screen 2. Share. Here we go. So my name is Klaas Moser. I'm Business Development Director for e-mobility for Lankwitzer. And what we do in e-mobility is insulation coatings. And we have done this for roughly about 12, 13 years. Started in Germany. Lankwitzer is a German company. And expanding in the world for, let's say, about 4 or 5 years now. Very active in India. So I liked what you mentioned before about India. And I totally agree to the statements which have been made about India. Very active region. Let's see. Why can't I change here? What we're going to look at today is basically the difference of durability between PET film, which is used very commonly on battery cells, if they're now cylindrical or they are prismatic cells. If we look at the throughput of PET film for the application is 6 parts per minute. Insulation coating, 60 parts per minute. So quite fast. If we look at the issues we hear from the market and see in the market as well about the adhering process, there is 99.5% production rate. So no failure with insulation coatings. Bubbles during application of PET film, of course, on coating not existing. Change of equipment for different cell size, not necessary for coating. You can use different cells, different type cells, different size cells through the same application equipment. Wrapping process is not easy to handle all the time. And the coating process is fully automated. The adhesion of the film against the can surface is normally very low on PET film. It's very high on UV insulation coating. We're going to look at this in the next slide. Poor vibration and friction performance, that's super important for cars. It's important for trucks on challenging roads in various parts of the world. Long-lasting protection. So the target for us now is up to 25 years. And significantly better thermal conductivity. So that's a rough overview. PET film to the left, UV insulation coatings to the right. And this is the main topic and the major advantage of the coating, the insulation coating. If you do a test, it's called lap shear test. So you coat 2 cells together or 2 panels together and you rip them apart. And it's always the glue failing. There is never any bare aluminum underneath, which comes up. If you look at the PET film, the PET film is always ripping off the battery cell and leaves bare exposed aluminum on the outside, which of course is very tricky if you have coolant, if you generate corrosion. So this battery cell will not last very long anymore. The reason for this, and now we're getting very technical, that we have on the coating only one glue film. It's the glue film in between the 2 coatings. You glue the battery packs together, or the cells together in the battery packs. You glue the cells together. You have one glue, and you got another coating film, and you got another cell. If you look at the PET foil as an example, you have normally three glue points. You got between the between the battery cell, you got the foil, then you got the glue, and then you got foil again, and then you got a glue film again. And it's this glue film here, which is normally damaged due to vibration, due to movement, slight movements in your pack. It's always damaged in this area between and leaves bare aluminium open.
Sorry, just a reminder of the time. Please come to an end. Otherwise, we
come
run
very
into
quickly
problems.
to an end. To the left, we see the UV coatings in terms of mechanical lab shear strength, and to the right, the adhesive films. So up to about 17 on the left on the coatings and barely nothing on the adhesive films. Last one. Similar is with the electrical climate after climate chamber. To the left, you see the UV coating. To the right, you see the adhesive films. So massive different beginning of life, end of life, beginning of life, end of life. And I believe this is it. This is where we are: Germany, China, Mexico, and India. This is it. Thank you very much. Oh, that was quick.
Yeah, 4 minutes run by fast. That is true. But thank you very much for the interesting overview. Maybe first question, it sounds like the coating is so much better than the PT isolation or insulation. Do you have some numbers, like how many batteries are actually produced by this coating technique compared to the PET films?
Up to now, we have produced about 800-900 million cells for one big car maker in Germany. We now starting for a big car maker in Sweden with similar quantities, and so on. Everybody which does this comparison between PET film and coating is moving towards coating. Lots of activities in India with variable companies, lots of activities in Europe with cell manufacturers, OEMs. So at the moment for us, it's full blast converting to insulation coating.
That sounds very promising and a growing market. And
massive.
Yeah, in batteries, there is so much innovation still to be implemented in the batteries produced right now. It's very inspiring to hear that. I think in the looking at the time, one short question is possible, and then we have to head over to the next speaker. I see Alex Chen, you have a question. You are still muted.
Please.
Alex, we can't hear you. You have to unmute yourself. Otherwise, write your question in the chat.
Hi. Hello. Yeah. Can you hear me? Thank you for your time. Yeah, Mr. Moser, could
Yes, we can hear you.
Yeah. Mr. Moser, could you tell us whether you use UV printing or UV spraying method for this technology?
It's UV technology.
UV printing or UV spraying?
I don't follow the question. UV? Can you just write me the question and I will send it back to you?
Yeah. UV printing, printing.
Oh, not UV printing. We're looking at UV printing, but currently we use UV coating.
UV coating, spraying, like spraying, yeah.
Yes.
Like the car building line, yes.
Yes.
Okay, I see. Thank you.
Thank you.
Thank you very much. And we go to the next speaker.
Yeah,